So let's continue with the next topic in Docker. So we'll see how to work with our image build activities, and also we'll talk about Docker volumes, Docker Compose, and then we'll get into the container orchestration tool like Docker Swarm and Kubernetes. Now let's get into this Docker volumes concept. So this is another important topic when it comes to your containerization. So when we talk about containers, right? So containers are not something new. Okay, so we are discussing about Docker container engine through which we can able to create some Docker containers, create images and all. So it was introduced in the year 2013 and it got popularity from 2015 onwards. It gains its popularity. So the point is, even before Docker, we were using the containers, the concepts of containers. We were using Linux containers for most of our Linux-based application packaging and all those stuff. So the packages, containers are not something new. So whenever we talk about the containers, right, the containers are used to run some application or a task. That's it. Any container you consider, it is the basic property of a container is to run some task or an application. That's it. So on our users perspective, developers perspective, we consider an application like a microservice application, or we call it as a monolith application, or we sometimes we call it as a 3-tier application or 2-tier application, right? So on developers perspective, we refer the application architecture like this. But on containers perspective, there are just two types of application. One, we call it as stateless application, and another thing is stateful application. That's it. So the containers are basically used for stateless application. Stateless application means application that doesn't require any state. It will not have any clue of execution. It will not have any trace of execution. That is what we call as stateless application. Any trace of execution is called as stateless application. So if you consider the applications, it just enters the address space, executes, and then once the process complete, just leaves address space. That's all. So there is no concept called state management, like when it entered and what is the current state, how long it is executed, and what are the logs it's generated, what are the reports generated. There is no clue about it. Such applications are called as a stateless application. And initially the containers are meant for executing this application or task. That's it. We never use containers to maintain the state of any application. That is a basic property of container. Containers are not the permanent entity. Till the task is present, the container will exist. If the task is over, the container will go to exit state. Or sometimes due to some application issues also, the containers might goes into unreachable state or gets into drain state. So we cannot expect the containers to be available 24/7. So we never store any data of that particular application. That is what we consider as a stateless application, and containers are meant for stateless applications only. But when microservice-based application architectures gains its popularity, there are thousands and thousands of microservices has to be deployed, has to be executed using containers. And every service that you execute has to generate some data, might need some data as an input. So such an applications, whatever we are going to use, right? So all those things can be managed and maintained as a stateful application. Got it? So any example you can consider, like if you're talking about a 3-tier application architecture, for example, like if I say 3-tier application. So what are the various layers in 3-tier application architecture? Okay, so when we talk about the any service, okay, like consider I have a web application. Like in that web application, there is a service called user login service or sign-in service. Like if you want to log into your Amazon.com, a real-time scenario. So if you want to log into your Amazon.com e-commerce web application, first you need to log in. When you click on that sign in button, it will expect your username, your password, and then it will allow you to enter your option. Once you click on sign in, it will take this data, validate it. Once it is valid, it will be verified from your database. If the data exists, it will allow you to proceed further. Otherwise, it says invalid user or password. So this is a basic workflow. So this service, whatever we are using here, it composed of 3 layers, like the front end layer. Okay. So through which users can able to interact with the application. This is called as user interface, right? So through this front end layer or user interface, the web page, we can allow the end users to access our application. And what are the inputs the user is providing or what are requests they are expecting, right? So that has to be processed through the application logic. So we call it as an application layer. So here, this is going to hold the business logic. And the third thing is your backend layer that is promptly meant for database, correct? So if you are running this as an application, there is not an issue. But if you try to containerize it, right, each and every layer will be running in its own container. Like for example, if you consider this particular scenario here, I have a user interface screen, I have a business application logic, and then I have a database layer. So this is my front end, my application logic, and then my database, the backend layer. And if it is a containerized application, each and every layer I can able to run as a container, like container 1, 2, and 3. Okay. So as we have seen already, containers are meant for running some task or application. That's it. It is not capable to hold any data by default. Even if you store the data also, it won't be permanent. Once the container goes to exit state, or if you leave with the process, the data will be cleaned up. You cannot restore the data. Okay. So now the point is, as an end user, if I access this application through a web browser, means I will interact with the front end layer and I'll be entering some input data, like it can be my username or password, whatever it is. That data is present within my container 1, and that data has to be transferred to my application layer to perform the data validation. And once the data is valid, the application layer will send the data to database to query the record. If the record is present, the database will send the response, and that response will be passed and sent to end users through the same web user interface. So this is how the data flow from your front-end layer to database, and from database to front-end layer in any real-time applications. So you understood the process of data flow, right? How the data is going to flow from front-end to back-end. Now, the point is, consider the user has entered the data in, and this container 1 is responsible to handle the data. This data has to be sent to application layer. So during that process, if this container goes into exit state due to some issue, the container is not responding, what will happen? You're not just going to lose that container, you're going to lose the data. The data, whatever entered by the user, will be losing the data also. So the key point here is, at any point of time, you can lose your container. There's no problem in that, but you should not lose the data, correct? At any level, you should never lose the data. That is the logic behind this volumes, Docker volumes. So what you're going to do here is, this is my host machine. In this host machine, we are going to run these containers. Obviously, right? We have a VM to run this thing. So what I'm going to means, I'm going to create one volume in this machine. So this is what we call it as a Docker volume for reference. And this Docker volume, whatever we created on that node, it will be directly mounted to the container volume. So the same volume can be shared with more than one container. Whenever the user enters the data in this container, since we have mounted that container volume with the host volume, what are the data you enter here, it will be automatically saved in the host volume. So even if you lose that container or container volume, your data is preserved here. And if application logic needs any data, means it is not going to directly get the data from container 1, it is going to access it from this host volume. So this is the way we can able to share the data with more than one container. Whenever you want to send any input to your container, or whenever you want to generate any output from the container, it can be stored within this container volume. So that's what we call it as a persistent volumes. Okay. So why we use the term persistent volume or persistent data means, at any point of time, the containers are not a permanent entity. You can lose your container, but you should not lose your data. On that perspective, how we can able to maintain the persistent data throughout your transaction? For that, we use one volume called Docker volume here. So the point here is, at any point of time, okay, whenever we talk about the persistent data in real-time environment, we never simply run any container. If the container is going to generate some data, or the application running inside the container, if it is going to generate some data, or if it requires any input, that can be handled through the volumes here. So in order to work on these volumes, we have a dedicated Docker volumes commands. Like for example, if you can see Docker volume list command, you can able to understand what it is all about from your console. So once you install Docker, you can able to verify that. And this Docker volumes are meant for some minimum amount of data. Okay, it can be a local volume or it can be some external volumes also, but in general, we'll be relying on the host level volumes. So I'll show you how to create these volumes now. Let me log into my console. See, volumes are just a storage. Okay, it can be a directory where you can be able to maintain some files, maintain some content. Okay, but database means it is a structured storage where we can able to maintain some relational data. Like if you're working on MySQL database server, or if you're working on Oracle database server, in order to store the data in the form of tables, in the form of database, we rely on the database, right? Database management system. So the volumes means, the volumes, it can be used to store your file system, or your database system. When I talk about the volume is just a storage. Okay. So in your C drive, for example, on your Windows machine, in the C drive, if you create any folder, actually that folder is just a volume where you can able to store some files. Correct. Similarly, if you install MySQL server and if you create any table, the table also is going to get stored in this particular database directory. That is considered as the database volume. So after volume is just a storage. What you're going to store there, whether it is meant for a file system or database system, that varies. And in real-time environment, these volumes can be procured from external storage medium or storage servers, or it can be from your on-premises storage servers also. Like in AWS, we have something called EBS volumes. If you're talking about Azure, means we have Azure disk, persistent disk, Google persistent disk. A lot of things are there. So we procure the volume and what type of data you're going to store, whether it is going to hold the file or database. For managing database, you'll be having a special category set of volumes actually. So let me get into this. So now let's consider Docker PS. I don't have any active containers. All right. So there's a command called Docker volume list command. So when I say Docker volume list, you can see it is going to get the list of volumes, driver name and the volume name. So as of now, the list is empty. So I can add this command here. It's a CLI command to work with Docker volume. And if you want to create a volume, you can use the same Docker volume command by using create. So Docker volume create followed by the volume name. So when I say Docker volume create followed by the volume name, a local volume will be created to manage your persistent data. So for example, Docker volume create followed by the volume name. It can be anything. Okay, like for example, skvol1. Okay, that's it. Now if I get the list of volumes, I can see one local volume has been created. So where this volume is created, in order to understand that, we can execute the inspect command. So Docker volume inspect followed by the volume name. So inspect is a command. Okay, it can be used to inspect any Docker object. It is not just for volume. Even if you have an image, if you want to understand the properties of image, let's say we have images, right? If you say Docker inspect Ubuntu, Docker inspect Tomcat, means you will get the complete architecture related information about that particular image. Like this, if you want to inspect the volume, you can use this command Docker volume inspect followed by the volume name. Here you can understand the basic properties of the volume, when it gets created and what is the mount point. This is a very important thing. So the sk-volume1 was created and maintained in this Docker volumes directory. So if you give cd to that volumes, you can see something called sk-vol1. Within that, you can have only one directory called data. So cd to that. So this is my default directory in my host machine. So I was talking about the common volume, right? In the host machine, this is what it is. So once a volume is created, you can attach this volume to your containers. So to do that, let's execute any container. Like I have some images here, right? Images. So what I'm going to do here is I'm going to use this Ubuntu image, Docker run -it. I can able to mount this using --mount key. We can able to mount this source equal to sk volume1 and the destination, destination that is equal to /skvol1. That's it. And which image I'm going to use here? It is Ubuntu image in bash mode because I'm going to run it in interactive mode. So I can use the bash terminal for interaction. So it is same. Okay, let me copy this command for you. Before I run this command, I just show you the differences. So what we usually do to create a container, we simply use docker run -it followed by that image name in bash mode. Now we can able to explore the file system. These are the default directories present in this container, right? I can able to create any folder or any file. I can able to maintain it. Once the container goes to exit state, we'll be losing the data. So let me exit from here. Now I want to run a container with these mount parameter. So what I'm going to do here is the volume, whatever I've created, this particular volume, I just want to attach it to the container volume. So source is my host volume. Destination is the container volume in this directory. You see? So Docker run -it, we are just setting up the mount point and attaching our host volume with the container volume. Now, if you run this container and if you say ls, you should be able to see the new folder is available now, skvol1. Earlier, you can't find that, but when you attach a volume, you can able to find the directory skvol1. So this is a common directory which is used to hold the data. Let's say this is my application container and this application is generating some data. It can be a log or a report or any artifacts. Let's say you're running your application build container. It will create some artifacts, right? So that artifacts can be stored in this particular volume. So if I go to that skvol1, I can able to create some file. Assume that this is the file. Okay, this is the file that is generated as part of this container execution. It is available within the container. Now, let's say, for example, we are just exiting from this container. We come out of it, or we are just remove the container by using docker rm command. Even if you remove the container, the data, whatever created on that particular container, it will be available in your host machine in this volume. So this is what the process of maintaining the persistent data. Even if you lose your container, the data is preserved in your host volume. Not only this, consider I want to create one container. To create the container or to run the container, I need to pass some runtime inputs. It can be my application properties or environment configurations or secrets, whatever data I want to share with the container. I can able to maintain the data within this volume. Let's say I can create one new file in file1.txt. I'm creating this file in my host machine now. So we have this file available. So with this, if I create a new container, I can mount or refer the same container to any number of, refer the same volume to any number of containers. Okay, so if I use docker run command with the same volume, and if I log into that volume and access the data, I can able to see the file here. So this is how you can able to share the data in and out of your container. Understood the logic? See, while running the container, while creating a container itself, you have to mount the volume. It is not like after running the container or after starting it, you can mount the volume. It's not possible. Before you start the container, you have to identify the volume, and as part of your run command only, you can able to mount it. So this run command is meant for this container. I exit from the container and I created another container now. Easy. And apart from that, so in real-time environment, we'll be attaching the volume from external storage servers. This is just a local storage. If you want, you can able to attach your external storage also. For that and all right, we need to rely on some container orchestration. So that's what you can learn in a Kubernetes module. So tomorrow while working on Kubernetes, you will get to know how we can able to handle the persistent volume from external storage servers. Because Docker is just for managing containers, okay? It is not an effective container orchestration tool. We have Docker Swarm for container orchestration, but still it is not that much capable to handle the production workload. So in order to manage your production level workload for huge or high scale applications, we'll be relying on the Kubernetes. So while working on Kubernetes, again, we will revisit this topic, but it will be at the very higher level. How we can able to attach a volume and how we can able to scale, auto scale those volumes, and how we can able to allocate in a static or dynamic mode. A lot of things are there to discuss. All right. So this is a concept behind container volumes. So whenever you want to maintain the container volume or container data, and if you want to maintain the persistent data through the transaction, it is recommended to attach or mount a volume to the container. Easy? Fine. And if you want, I can add those commands, whatever we have created. I think volume list, docker volume create command I used, remember, followed by the volume name. And also I use one more command, docker volume inspect, followed by the volume name. And then we can able to mount it. Like this, you can able to create any number of volumes and attach it to any number of containers. There's no limitations there. Easy? Fine. So this is about your container volumes or Docker volumes. So the next we'll see how to create container images. So that is the next topic in the list. So in order to create your container images, we'll be working on two different commands. Like we use docker commit and docker build. So when I say docker commit, it is used to create a container image based upon the reference of any existing container. For example, you can use your volumes actually in real time. Persistent volume claim and all, it is in your container organization tool. Okay. While working on Kubernetes, we'll discuss about it. Persistent volume claim, we'll discuss during our Kubernetes module. So now the thing is that, consider a scenario. I have created a container. In this container, I have installed some build tools. Assume that I just want to use this container to build my application. So in order to build the application, what are the build tools we need? Like starting from Git, JDK, and Maven, I'll be installing all the required tools in my container, and I can able to clone the repository, perform the Maven build, and I can able to preserve that artifacts in particular volume. If I attach that volume to this container, I can able to safely copy that artifacts to that volume. So even if I delete the container, I have the data, the artifacts available in the volume. Like that, I can able to maintain some build using my container. And once the container goes to exit state, if I want, I can able to start the container and create a new build with a new source code. Everything is possible. But the point is, you can able to start or stop the container only if the container is present. The scope of the container is within the machine, because it is going to execute as a process. Tomorrow, if you want to share or reuse this particular container or if any one of your team member wants to perform the same build activity and they are looking for this container, means you cannot directly copy the container from your machine to another machine. You cannot copy the containers from one machine to another machine because it is a process that executes within a machine. So how I can able to copy the properties of the container means I can able to create one image out of this. So based upon the existing container reference, I can create one image and that image can be published to your container registry. And once the image is available in the registry, anyone can able to pull that image into their local machine and start creating running a container out of it. So how to create a container image based upon the existing container reference means that is done through your Docker commit command. So Docker commit is used to create a container image based on the existing container reference. Simple. Based on the existing container reference, it creates it. The syntax for this Docker commit also it's very simple. Like you can simply use Docker commit followed by that image name. What are the image you want to create? But the point is to create an image, you need an input parameter. That input parameter is what your container ID. So syntax for this is Docker commit followed by that container ID, any container reference which you want to use, followed by the image name, the new image name. If you want to create an image with a versioning or tag, you can able to give the tag number there. It is optional. If you're not using any tag, by default, it creates the latest as a tag. Or if you specify the tag name, you should always refer the tag name. And if your intention is to publish this image to your container registry, to your target, any container registry, can be a Docker Hub or any other containers like Elastic Container Registries or Azure Container Registries, you have to prefix the image name with that repository name. Okay. So yesterday I was talking about repositories, right? Repositories are the subset of a container registry. So just prefix the container repository name followed by the new image. If your intention is to publish to container registry, you do it. Otherwise, you can simply create an image and have it local machine. So this is a general syntax for commit. So how to work on this means, okay. So we have three or two images now. Okay, I'll give you one example here first. Let's use this Ubuntu image and create one container. Docker run -it followed by the image name like Ubuntu in bash terminal. Now, in this particular image or a container which gets created, you won't find anything like Git and all, right? So what I can do, my requirement is I want to use this container to build my Java-based web application. So I need to install all the required build tools. So let me update the package apt update -y. All these things we are doing within a container, and let me install Git. So once Git is installed, what are the tools we need for our application, Java application build? Maven. So if you are okay with the latest version of JDK, you can directly install Maven. It will search for the default JDK version. If it is not present in your machine, it will install the latest version and then it installs Maven on top of it. So apt install Maven. See, it is searching for JDK. It is not available. So it is trying to install OpenJDK 21. And once JDK is installed, then on top of it, it will install your Maven package. So now that Maven is installed, if I say MVN version, you can see there's a Maven version available and this is the Git which is installed. So this Maven is referring to Java OpenJDK 21 version. So now I have a build tool available in this container. If I want, I can use git clone command to clone the source code repository, and I can give mvn clean package command to create a package, and that package can be maintained in a separate volume. That is also possible. So like this, I can able to maintain the container and perform build. Once the process completes, I can exit from the container. I can create another container to build a different type of application. So like this, I can have one build server and I can able to create any number of containers to build my application, create the artifacts. Understood logic, right? Correct. So now the point is the scope of the container, it is present within the machine. This one. This is the latest container which we just created. And in this container only, we have installed JDK, Git, and then Maven. If I start the container, let's say I can use Docker start followed by the container ID. I can start the container. The container must be in start state now. Sorry. And I can use Docker exe command to log into the container. See, the tool, whatever we installed, it is available because the scope of the container is within the machine. I can able to start or stop the container at any number of times. Easy. But I cannot directly copy this container to any other target environment. So to do that, I need to create an image out of it. So how to create an image based upon the existing container reference means you can use your Docker commit command. So in our case, we are going to create one image. At this point, we just have Ubuntu and Tomcat. So let me create a new image here using Docker commit command followed by the container ID. So I want to use this container ID and the new image name. So consider the image, whatever I'm going to create, I want to publish to my container registry. So in my container registry, I have a repository and I need to use a repository name. So the syntax or example will be docker commit followed by the container ID and the repository name slash the container like skmvn build image one. If I want, I can able to have some tag number like 1.0, something like this. So skmvn build image one is the image. So I can execute this command. So we have something called server templating. Okay, server templates. So even this way of creating a image is not something new. Like people who are working on Amazon, right? If you want to launch a node, you're using your AMI. AMI means Amazon Machine Image. So it is a template, server template, okay, which contains the software configuration like your OS application server that is required to launch your instance. Similarly, here we are going to create one template, a container template through which we can able to launch a new container. So when I launch that container, automatically the Git and all the required build tools should be available in that machine, in that container. That's what the idea here. So now that I have created one container and it's container image, and if I say Docker images, you can see one new image has been created with this tag. So if I have this image, what I can do, I can simply run the Docker run -it followed by the image name. So whenever you create an image with the tag, you have to enter the tag name. If the tag is not assigned, you can directly use the image name because it assigns the latest as a tag. But in this case, we assign v1.0, just enter that one and use a bash. That's it. So now I am within this container. And if I say git version, I should be able to see that git is installed. So this template, whatever we have created, the image, the static file, it is already having the properties of my build tools. So I can able to download this image from the container registry and run in any target machine. So next we'll see how to use your Docker build. So the difference between Docker commit and Docker build is when we say Docker commit, it is used to create an image based upon the existing container reference. But I don't have any container reference. I don't have any existing container. I want to create an image from the scratch. For that, we use Docker build. So in real-time environment, this Docker commit commands are used by the administrators to create some server templates like this or container templates. But the application developers, if they want to create their application images, they can use this Docker build. So the basic difference here is Docker build is used to create a container image based on the Dockerfile definitions. Okay, so that is a basic difference between your Docker commit and Docker build. And Dockerfile, it is considered as a manifest file, which is going to define the properties of the container that you're going to create. Like I was talking about the containerization, right? Like I was talking about the containerization, the container image and all. So it composed of various layers, and the layers can be created using Dockerfile instruction. Remember, I used the term yesterday, Dockerfile. So whenever you want to build or create some incremental changes in your existing container image, you can use your Dockerfile, and based upon Dockerfile instructions, you can able to create or update your container images. So Docker build is promptly used by the application developers, and it is the responsible of developers to maintain the Docker file in the application. Okay, that is a basic difference. So as like how the developers maintain the application source code, in the same manner, they will maintain this Docker file in their application source code repository. So if you have this file available as part of your CI/CD pipeline, you can able to use a file and build one new image, application image. So the point here is how to create a Docker file. That is a very important thing to consider. So these Docker files composed of various instructions. Okay, and these instructions are used to create the layers of container images. So this is what the scenario here. So using this Docker file only, we are going to create an image, and this Docker file is used to create the layers of your container image. So it is not something new, okay? Like in my yesterday's session, I was talking about the container registry, right? You can take any image, like if you're talking about Ubuntu, and if you go to the latest version of this Ubuntu image, see here, it composed of various layers, and these layers are developed based upon the parameters or the instructions. Similarly, if you consider your Tomcat, so it composed of various layers. So the layers are nothing but the instructions that is used to create, or it's like a building blocks for your container image. So all your incremental changes will be maintained in this, and it is always recommended to maintain less number of layers in your definition. So layers, it's very simple. Okay, see, already you must have configured Tomcat server on your VM, right? So what are steps you perform there? First, you have to identify your target server, that is your QA server, where you want to install Tomcat with the valid operating system. And once you identify the underlying VM with the operating system, you'll be installing your, you'll be upgrading your default packages, and you need to install JDK. Once JDK is installed, you have to update the JDK's environmental variable. And once it is done, you have to download Tomcat, extract it, and you need to run that script startup.sh shell script by referring the existing JDK path, right? And then that Tomcat service is exposed to port 8080 by default, right? So these are all the various steps we performed in our VM to set up a Tomcat server. So the steps, whatever we discussed now, it's all defined using this instructions here. Like if you go through this, we have copy instruction, CMD, run, and what is it called? ENB, work directory, expose, CMD. Like there's a lot of instructions are used to build your image layers. So as a developer, it is their responsibility to create these layers. And in real-time environment, if you're focusing on application deployments or application containerization, we use Dockerfile. Most of the cases, most of the time, developers will use this Dockerfile to create an image. On admin perspective, as a DevOps admin or infrastructure on infrastructure perspective, if you want to create some server templating or container templates, we can use it Docker commit. Based upon the existing container, we can create it. So it is purely depends upon requirement. And developers will never use Docker commit in their process of creating a CSD pipeline and all. We never encourage. They will be using a Dockerfile, and Dockerfile should be part of the source code repository. So as a DevOps engineers, we are not going to create any Dockerfile for application builds and all, but you should know, you should aware of the Dockerfile instructions, like what all the instructions we have, we can use for that matter. So we have something called from instruction. We have something called run instruction. We have something called copy, CP, add. We have something called expose, and we can use something like work directory. Okay. And we can use something like CMD, entry point. Like this, there are some instructions used by the developers to prepare the image. So at least you should know, you should aware of all these instructions before you actually write your Docker file. So what does the need for this from instruction means? It is used to identify the base image. Okay. For example, if you want to use your Ubuntu as a base image to set up your Java build means, you can use that image name under the instruction. And run instruction is used to execute any package manager task. Okay. Any script or any task if you want to execute as part of it, any package manager if you want to execute, you can able to use a run instruction there. And next thing is about copy instruction. This copy instruction is used to copy the files from the host volume to the container volume. Correct. From your host volume, if you want to copy any file into the container volume, you can use a copy instruction. And another important thing is CP. CP also it is used to copy it. Okay, so this is also used to what is this? Used to copy the files within the container volume. Easy. So consider within a volume, within a container, if you want to transfer data from one directory to another directory, you can use CP instruction. But if you want to copy the data or a file from one external host volume to your container volume, you use your COPY instruction. And this add instruction also the same, used to copy the files from a host volume as well as from web URL. Like normally we use the wget command to download the file from web, right? So all those things can be done with the help of your add. So whether the file is present in host machine or in your web service, you can able to download the file using add instruction. And expose command is used to set the default port, container port, we can say. And the working directory is used to set the current working directory. Okay. So let's say I want to copy the file from one folder to another folder. That source folder can be set using this work directory. From there, you can able to copy the data to your target folder. And the CMD instruction, it is used to pass the runtime inputs command, or used to set the startup task, or pass the runtime input command or a task to container. So it means, consider I want to start a container. When I initialize the container, I need to define some startup task. So that startup task can be defined with the help of your CMD. Okay. This entry point also, it is meant for the same purpose. Entry point also uses to set the startup task of the container, but the difference is we cannot change the task at runtime. So that is a basic difference between CMD and entry point. If you use CMD means you can able to change the command or task at runtime. But if you define any command as a entry point, you cannot change at runtime. It is a fixed entity without your knowledge. Like let me exit from this container. And if I say docker ps-a, you can see we have executed these many containers, right? We have created these many containers, and you can see there is something called command. So you can see some default commands like catalog.sh run command. If you see the Tomcat image definition, it is having the very last command as CMD followed by that command. So it means when I start this container, I should execute this script. This is a startup task. So the startup task for any container is defined using this cmd instruction. But what we did here, in this case, we have directly used a startup task. We never changed it. But in this case, if you noticed, I used bash. It means I was executing the container in an interactive mode. So I'm trying to override the commands, whatever we defined in that initial config file actually. So whenever you define any command using CMD, that can be changed at runtime. But if you define the same command as the entry point in the Docker file, you cannot change it. Always the container will start with the task. Easy. So that is what the requirement. And also we have something called env. Env also is another instruction we can say. Like it is to set up your environment variable. Okay. Like in this case also, if you noticed, we have something called Tomcat env. Like after installing JDK, they have set the Java home variable. So just to specify the Java home variable or environment variable, we can use env instruction in your Dockerfile. Easy. Now coming to our example. So in our case, okay, let me use the same notation. Okay, what are things we did using your Docker commit? I'll show you how to do it with your Docker file. So for that, what you're going to do means we are going to create one file here. File name is Docker file. Should be exactly same D caps. And what I'm going to do here is I'm going to use a from instruction. What is the purpose of from instruction? I want to refer the base image. So what is the base image we used in this image definition? It is Ubuntu, right? I can use the same. And on top of that, what we did, I have started the container interactive mode and install all the required build tools, right? Based upon that, I prepared the image. Similarly, I have identified the base image here, and I'm going to use a run instruction to execute update first, and run instruction to install git, and same run instruction to install what do you call that, Maven. Simple. This is my simple Docker file to create an image. What are things we did with your previous commit command? We can actually through Docker build using Docker file here. Simple. So let me create a new file. I'm going to use a base image as Ubuntu, and I'll be running this update, install git and Maven. So save the file. That's it. Cat Dockerfile. Now, once the Docker file is ready, so as we discussed already, this Docker build command is used to create a container image based on the Docker file definition. So we have created Docker file now. What next? We are going to use our Docker build command. So the syntax for Docker build command is, what I can say, Docker build followed by that tag like terminal -t followed by the image name. So image name also, you can use the same notation, like what are things I was talking about, right? You can use the same notation here, space dot. So here, this dot refers to the Docker file. Okay, that means in which directory you have your Docker file, just execute this build command from the directory. So this dot refers to the Docker file reference. And to make it with an example, you can use Docker build -t followed by the name of repository. You can use something like this, or this time I'll show you without any tag, Docker sk git maven build. Okay, like this. I'm not going to use any tag here. Let's see how it gets created. So this is the command Docker build -t followed by that new image name by using the existing Docker file reference. So run this command in the directory where you have a Docker file. So if I run this command, so now it is executing the instructions one by one. It has installed git. If you can see this example here. So when I execute the command Docker build command, you can see it has started use the base image as a reference, and then it has executed the second instruction to update the default packages. Upon updating package, it is installing git, and the fourth task is to install Maven, and that is also, I guess it's completed now. It's done. So now if I say Docker images, I can see a new image has been created with the tag as latest, because we never explicitly give any tag name there, right? That's it. So now if you want, you can able to create a new container out of it using Docker run command in an interactive mode. Use this image name as your reference in bash. So you can able to find what are the tools you want to maintain. It is available there. So either you can use the Docker build command or Docker commit command. If you are using your Docker containers, and if the container is already equipped with all the required tools, your Docker commit will be the easiest way to create a new image, because we're just going to use the reference of that container ID. That's it. But if you don't have any such containers, if you want to create everything from the scratch, in that case, you can use your Docker file. Okay, I'll give you one scenario here. If you want, I can consider the thing which you already did. In your previous module, you have created a Tomcat server, right? Correct. So what are the steps you use there in Tomcat server creation? You launched a node, identify your inbound, what you call the port 8080, and then you install JDK, set up the environment variable, and then configure a Tomcat service, started a service, and able to access the web browser, right? Using that particular method, you can able to test one application service that runs in port 8080. Simple. Same thing can you able to perform using this container. I want to run my Java web-based application. I created artifacts and I just want to run that artifacts within my container. I can use my Tomcat itself. I think already we have a Tomcat image available here, right? Yesterday we use this. You can use the same Tomcat as a reference. Can you able to make it? So what is the input required to run your application? So when we talk about this particular scenario, right? This is what the actual process of containerization. So if you remember, in our yesterday session, we were discussing about the development or deployment perspective, right? So developers will be creating the application artifacts, and based upon that artifacts, they're going to create an application image. My question is, once the artifact is ready, how we can able to create an image using Docker build command? Simple as that. So the first requirement is we should have a base image. If you already have a Tomcat, you can consider Tomcat as a base image, and you need this application artifacts as your input. So we are going to package our application along with the dependency and create one new image here. So in that case, if you remember, we have installed Tomcat in which server? Because I need my artifacts now. I mean, this war file I need, right? So where the war file is present now? In that slave node, that is a build server. In that build server, we have the application artifacts. And I was expecting you to install Docker in the same slave node. Remember, even I have installed in my slave node only. So if it is a slave node, definitely the application artifacts will be here in this machine under the DevOps admin's home directory. Remember? So my requirement is I need this war file. I want this war file to be copied inside my container. I want to run this application using my container. This is my build server. I never installed Tomcat in this VM. So this particular Docker daemon, right? It is completely owned by root user now. And this Docker is having its own Docker group. So if I want this DevOps admin user to access Docker, the DevOps admin user should be part of that Docker group. Simple. So exit from here first. And as a root user, what is the command to add a user to doc any group? User mod command. So what I can do here is I can use that command like user mod -ag followed by the group name doc followed by the user ID DevOps admin. Simple. Now, if I log into this machine as a DevOps admin user, and if I say Docker PS, I'm able to access this. Correct? Easy. So have this in your checklist. So user mod -ag Docker followed by the user ID DevOps admin. And now you need to create one Docker file. So what are all the instructions we can have in this Docker file? So what I can do here is I already have an Docker images. I have this image called Tomcat that is 8.0. So I can use the same image name. I don't want to download anything new. Let it be the same. Now, once the base image is identified, what is the basic scenario here? Yesterday I was running this Tomcat image. Remember, ps-a-it followed by the image name Tomcat 8.0 in bash mode. So when I execute my Tomcat container, it is executing in its default directory. That is user local Tomcat. This is a default directory for Tomcat, and within this directory, if you see here, we have something called web apps folder. So if you navigate to the web apps folder, you can able to see the application artifacts directory, the host manager, root, everything will be there. So if you recollect our Jenkins module, I was showing you the target path. Remember, I was talking about where is it? I think we went too far. Yeah, this one. So I was talking about the deployment process. So when it comes to your deployment, we need to identify the target directory. So in my Tomcat web server, this is a default Tomcat directory. Under Tomcat, we have web apps folder. Within the web apps folder, I need to copy my artifacts. Similarly, in my container, I have web apps folder. So this will be my target folder now, correct? This is my target folder. Then what will be the source? So as per my application build activity, the war file, whatever we have created is available in the target folder. So this is my source directory /war file. Easy. So this is my host volume and this is my container volume. So my requirement is from this host, I want to copy this artifacts. What are the artifacts we have created in that machine? I just want to copy it to my container volume. If you want to explicitly use your port mapping, I mean, expose your port number, you can use expose followed by the port 8080 or 8089, whatever you want to give, you can specify. And one more important thing, you don't need to give a complete home directory or source directory also. If your project is already having your Dockerfile, let's say, for example, I told you this Dockerfile is something created by the developers and it will be maintained in the application source code directory. So if it is maintained in the application source code directory means it will be available somewhere in this directory itself, correct? Vi Dockerfile. Am I right? When you perform SEM checkout, along with this file, your source code will get downloaded to this workspace folder. So automatically this Docker file will be available in this directory. Easy. And in the directory, you can able to refer your content. Like let me create one file here for your reference, and I can keep all these content there, like what are things I need. But in this case, I can simply refer to my target folder. That's it. Save this file. And I just save the file, and this is file content. So now in this directory, I have a Docker file. So what I can do, I can use a Docker build command, Docker build -t followed by the image name. Like I can create one image like dot. So dot refers to the Docker file, which is present in my directory. See what's happening here? Based upon this reference, the Dockerfile reference, it has used the Tomcat as a base image and executed the copy instruction that copies the war file from the target folder into the Tomcat web apps folder. And then it is exposed to port 8089. Now, if I use a command docker images command, you can see a new image has been created with version 1.0 as a tag. So what I can do, I can use docker run -it followed by that image name using bash term. So like this, we can able to create, I think I missed that version number. Let me give a version number also because we added 1.0, right? So I can use that version number. And now you can see we are inside this container. Earlier, when I execute this container, it was saying like this image is not present locally because I missed that version number. Now I just gave the version number and I logged into my container now. See here, after logging to the container, just navigate to that web apps folder, and in that web apps folder, you can see that war file has been copied. Easy. So this activity was done through your Docker file. Using this copy instruction, we have identified the war file from the target folder and copied to the container volume. Now my application artifacts is present in my container volume. So let me exit from this. I just executed this as a startup task. Okay, nothing else. I mean, in an interactive mode. Let me exit from here. And all that I'm going to do here is I'm going to create one new container. There is no running containers, or it is running, but it is not using any port there. It is an exit state now. Okay. So what we can do here is we can create one new container, docker run, can be in interactive mode using the container image name. This one be 1.0. That's it. Docker run -it followed by the image name. I don't want to change the command to bash and all. By default, it will be having the cmd catalina.sh. So it will start my Tomcat service. See, one new service has been started. I'm just going step by step. Okay, you should understand how the process is, and this is just to verify whether the artifact is being copied successfully to the service or not. Now you can see the Tomcat service is up and running, and if you can see the log here, you can able to find the web apps folder, and within that web apps folder, you should be able to see the artifacts. The artifacts, whatever we copied, it should be available in that web apps folder. This one, see, it has deployed. Deployment of web application archive. This war file has finished. So whenever you create any container, I mean related to the Tomcat, it gets into that deployment path and check for the deployment, whether it is having any war file or not. If it is not present, it just have the empty folder with the root Tomcat root or index.html page. But now we explicitly use this particular war file here. So this is how we can start any container using your artifacts. It is just a process of starting the container. It doesn't mean that you can access through a web browser. If you want to access the web browser, what do you need? Build the port mapping. Say for example, sorry, what do you call that? Sorry, Docker PS. So now you can see we have the ports, right? So while creating this particular container, I use a port 8089. So, but I haven't enabled the port mapping. So what I can do, let me stop this container for now because already it is getting overloaded with a lot of images and containers. So docker ps stop followed by the container ID. Once it is stopped, or you can simply say Control C from here, it will stop that. So now let's start a container again with proper port mapping. Docker images, docker run -it0. What is the option to enable the port mapping? P means publish followed by the host port and the container port. So host port, it can be anything because I've already updated the security group of this node with allow all traffic. Correct. So no need to worry about that. We have all ports enabled since it's a demo server. So I can use -p 8085:8089. Easy. That's it. So now it is starting this, and you can able to verify all your deployment artifacts, everything should be up and running, right? One second, let me log in again. All right, so now that you can see, we have created some images which are present in our local machine, right? And if you want to publish this to your container registry, you have to first log into your container registry through Docker CLI. So next step, we'll see how to publish. So when I say publishing the images to container registry, what is this? container registry. So here we are going to use Docker Hub. So usually if you want to access your Docker Hub through your CLI or through any external APIs, we use the Docker Hub access token. Okay, we use the Docker Hub access token. So it is same as like how you have created your access token in your GitHub repository. So here in Docker Hub also we have to create one access token, and with that access token you can able to log into your container registry and push these images. So let me log into that first. This is our container registry. So just you log into your container registry first and go to your, you need to log into this also, right? It's getting expired. Okay, let me log in again. So now go to your account level settings. So once your login is successful, on your account name, just something called account settings. So go to this account settings option, and from this account settings, you should be able to see something called security tab. Okay, under the security tab, you can see something called personal access tokens. Okay, so just click on that personal access token under security tab. It'll open up a page where you can generate new token. Click on generate new token and enter the token name. For example, I can say SK Docker T1 and specify the access mode, like what level of access you want to give. Like you can able to enable the read-only access or read, write, or delete. Everything is possible. So using this token, I can able to read, write, or delete the container images or repositories from this container registry. So just specify the name and the access permission and click on generate. That's it. So your new access token will be created here with this permission, and it is giving recommendation. Like if you want to use this access token from your Docker CLI, run this Docker login command first, and then it will prompt for the password, enter this access token. So this is a command that is used to log into your container registry. And when it is prompting for the password, just enter the access token which you have created here. Simple. So with this will be your account ID, Docker Hub account ID. With this account ID, just log into the system and entering your password. Easy. Now, let me show you how to do this. So the basic command to access your container registry or container repository means it's the same. Like how we used your Docker login command, first log into that and enter the password. Once the login is successful, you can directly give your push command, like Docker push command followed by the image name. So first let's run this command. We can access from the internet, right? What's wrong with that? I've deployed my application and it should be accessible through your web browser if you use your proper port number. It should be fine. There is no problem in that. But before you actually do that activity, if you want to publish your container images to a container registry, you need to create access token and log into that particular container registry. So we are just in a process of publishing the image to container registry. So we have logged into this container registry now. And while it is asking for the password, just enter the code, whatever you created here. Easy. It is a hidden field. Okay, just copy and right click. It is a hidden field, so it won't expect any other thing. Just give enter. That's it. So now with these two details, your login is successful. Okay, once the login is successful, then you can directly run a command, that is Docker push followed by the image name, like which image you want to use. I want to publish any of these images which I created. I can use that image name. That's it. So Loxi ETA is the repository name. The repository is nothing but the one which we have available by default. So this is the repository, Loxi ETA. So using this ID, I just want to publish my image. Simple. So Docker push followed by that image name. If your image is assigned with any tag, like here, if you want to consider this particular image, in that case, your push command will be something like this: Docker push followed by that tag number. It's mandatory. If you have created an image with the tag, you need to enclose the tag number there. If not, you can simply give the image name, and by default, it will pick up the latest as a tag. Easy. Now, once you are clear with this particular command, let me run this here. Yeah. So I'm going to publish this image, Docker push followed by that image name. So once we are clear with this, it will be easy for you to explore these images in your target, that is in your any target machine like QA or UAT, anything, anywhere. So it is trying to publish this image. Yeah, it's done. So now you can get into your container registry and let me refresh this page. See the latest image just a minute ago. It has published one new image, skget MVN image. Okay, so this is the latest version. The tag is assigned with the latest. And what we did here, we were using the base image as Ubuntu. I think it is Ubuntu image, right? Git MVN image. So we have used from instruction to capture the base image as Ubuntu, and on top of it, we have prepared some layers. So those layers is what you're seeing here, like apt update, apt install git, and apt install maven. So these are three different layers we have created through that Dockerfile. Easy. So this is how we create an image and publish to any container. The process similar. Even if you're working on your managed services, whether it is your Elastic Container Service or Elastic Container Registry, you'll be following same procedure. And this will be the public view of my image. So if you want to use this image, you can directly use Docker pull command from your Docker machine. From where you install Docker, just simply run Docker pull followed by the image name. You can download this image to your local and create a container out of it. Easy. Whenever we talk about the application image, that image should be composed with some artifacts, right? The image means what? It's just a package. It is just a package with all the dependencies. So if you are considering this particular image, we have prepared this image based upon Tomcat. I want to run my web application using the Tomcat service. So I use Tomcat as a base image and prepared it. So when I use a Tomcat as a base image, all the dependencies are fulfilled there itself. Like it will be having the JDK as well as Tomcat, and it ultimately starts the Tomcat service. That environment type is defined by default. Everything is fulfilled when you use your Tomcat as a base image. And then only thing is you need to use a copy command to copy your artifacts to that particular container volume. That's it. That's what I've given in this manifest file. Easy. Okay, see, when we talk about the image, it is just a static file here. Okay, so we are just trying to publish this image. The image, whatever we have created here, this image we are just publishing or managing in your container. It's very simple. No, it's something like, in your GitHub environment, you have published or you pushed your changes from your local repository to remote repository, right? Similarly, here in my local machine, I have created one image and I just want to push it to my container registry. So it depends upon the level of access. People who have access to this or within that internet, I can able to share my images to my team. That is how we publish the images. So once the image is available here, tomorrow once we start with Kubernetes, I'll show you how to use this image for deployment. So there only your container orchestration tools like Dockerfile or Kubernetes will come into picture. Okay, there are a lot of topics to be covered. What we did so far, it's all just a very basic thing. We just created an image and pushed to the containers. But the next important thing is your container orchestration tool. So when I say container orchestration tool, we have containers basically, right? Even I was giving some examples here using your 3-day applications and all. Okay, so this is my 3-day application. And if I containerized it, each and every layer will be having its own container. See, three like this. We have 3 containers responsible to run this particular service. So if I consider this as one microservice, in order to run this microservice, I need all these 3 containers should be up and running, correct? If any one container is down, it will impact the entire service. So how we can able to run more than one container as a service? That's very important here. We cannot run the containers one after the other. All these containers are responsible to enable one service. It means all these containers should be up and running at the same time. If you use a Docker run command to create this container, and then if you try to start container 2 and 3, means you are running this in a sequential manner. That is not the case here. At service level, what all the containers associated to that service, all these containers should run in parallel. It should start and stop at the same time. So how we can achieve this? With a simple Docker run command, we cannot achieve this. For that, what we need means we need one additional utility or a plugin or extension to your Docker. That is what we call it as a Docker Compose. So Docker Compose is an extension to Docker engine. So the purpose of this Docker Compose is used to run more than one container as a service. Simple as that. So what I'm going to do here is I'll be creating the service definition. Okay, we'll create one service definition. And once the service definition is created, all that we can do here is we can able to use that service definition to run all these containers and or start all these containers, stop the containers at the same time. So how to create a service definition means these service definitions are created using what is it called? This YAML file. Okay, this is also called as a manifest file. Okay. So we have to prepare one YAML file. In that YAML file, you have to identify more than one containers. What are the containers you want to execute? All those containers should be defined in that manifest file. And once the file is ready, you'll be using this Docker Compose command to start that particular manifest file. And as I said, Docker Compose is an extension to Docker engine. It means when you install Docker engine, this Docker Compose is not part of that package. We have to install it separately. There is a separate installation procedure to configure and manage this Docker Compose. So if you go to the official page here, so already I shared one link with you, right, to install Docker Compose. So from the same page itself, you can understand how to install Docker Compose. And it's a very straightforward command, okay, like identify the package and download it and install it. Simple. I'll show you a demo of how we can use Docker Compose and create a service definitions and all other stuff. Let me first So here it is. So let me put this in your notes. Okay. So here you can able to see the steps to install Docker Compose on your machine. If it is a Ubuntu machine, follow these steps. Okay. So like you can use your apt get updates and install Docker Compose plugin, and then you can able to check the version of it. And once it is done, you can able to prepare one manifest file and start using it. So this is using package manager, you can install it. Or if you want to install it manually, there's a step, install the plugins manually. So we'll be using this method. So you need to execute all these commands. It is nothing but a process of downloading the package and then installing it and then giving access to the user who can handle or access that particular Docker Compose. Simple. So prerequisite is first you need to install a docker.io, and on top of it, you're going to install this plugin. So follow this procedure, install the plugins manually, because this apt package managers, if you do that, means you have to explicitly enable the access and all. Install anyways, it is a manual process. So instead of that, directly you can start with this process, download the package, extract it, and then install it. Once this is done, you can able to use your Docker Compose command. This is a CLI command for Docker Compose. Docker Compose followed by the version or up command or down command, you can use it. All right. So this is all about managing your Docker Compose. Correct. And apart from that, there is something called Docker Swarm. When we talk about the container orchestration, we have all these things comes into picture. First thing is to execute multiple containers as a service. That is by using Docker Compose here. Similarly, we have something called Docker Swarm. So when I say Docker Swarm, right, it is a container orchestration tool. Okay. It is a container orchestration tool, and it is meant only for Docker containers. Okay. So the purpose of this Docker Swarm is to ensure high availability of containers. Why? Because whenever we deploy any container, that container should be available 24/7 if it is deployed in production environment. Even if one container is down, it will impact the entire service. So how we can able to ensure high availability of a container means by using the container orchestration tool like Docker Swarm. And this Docker Swarm can able to create replicas of containers. For example, if you create 5 replicas, means the 5 instances of the containers will be up and running. And even if one instance is down, it has 4 other instances to support application. So it creates replicas of containers to ensure high availability. Right. So we are learning about Docker Swarm now, okay, because maybe it is being used in few lightweight application or architecture. But in real-time environment, even in my current project also, not most of the cases, people who are relying on the production level implementation, we never rely on Docker Swarm. Okay, Docker Swarm is having very limited capability in managing or orchestrating your containers. If you want to use container orchestration within your non-prod environment, like dev QA means, it's fine. Or consider at enterprise level, there is a very limited amount of application deployments going to happen. It is not like a very frequent day-to-day builds and deployments. Very, like once in a month, if you want to do some deployments and if you want to maintain such availability, or if the application volume is very less, in that case, we can prefer Docker Swarm for that environment. But whenever there is an opportunity to scale up your business and scale up the services, like for example, today you have around 100 services. Down the line, if you want to update to 200 plus service, means if you're relying on Docker Swarm, it is not that possible to scale up. Correct. So the main drawback in using or Docker Swarm is this auto scaling and load balancing is not possible with Docker Swarm. Okay, these are the two important things. But these are two important things that is must to have in production level implementation. Because in production level implementation, if I deploy anything, the underlying infrastructure, whether it is your vertical scaling or your horizontal scaling, it should happen. I should be able to scale up or scale down my application, right? My infrastructure. But in Docker Swarm, it is not possible to automate that, but manually you can able to configure it one by one. So that is the reason we never recommend Docker Swarm for high volume enterprise level applications in production environment. In non-prod, yes, you can do that. That's not an issue. So how we can able to overcome these issues? What does an alternative means? So the alternative to Docker Swarm is your Kubernetes. That's what we're going to learn in the upcoming sessions. All right. So Kubernetes, it is also a container orchestration tool, but it is not just for Docker containers. Okay. It supports all type of containers like your Linux containers or Podman, any container. If you want to orchestrate, if you want to ensure high availability, you can use it. There also we have replicas. We can create some replicas to ensure high availability, right? And Kubernetes supports auto scaling and load balancing. Okay, that is one of the essential components or features we need in production level implementation. And not only that, the main advantage of using Kubernetes is the self-healing capability. For example, consider my requirement is at any point of time, I want 5 instances of containers should be up and running. Correct. 5 copies of my container should be up and running. That is my desired state. So in order to enable or ensure the desired state of the container, your Kubernetes can continuously monitor. There is something called controller objects through which even if one instance of container pod is down, automatically your control object can spin up a new pod or container and support application. And during your DevOps model, we talked about continuous integration, continuous delivery deployment, right? Remember? So whenever we talk about continuous delivery, it expects the manual approval for production release, and it might lead to some downtime during production implementation. But the continuous deployment approach doesn't require any manual intervention, and without any downtime, we can able to upgrade our applications that is running in a production environment. If you want to do some sort of enhancement, or if you want to introduce new release or feature, without any downtime, you can able to achieve that. So now how it is possible means Kubernetes is having some capabilities like controller objects, services, right? Through which it can able to auto heal. Like even if the node is down, it can able to heal itself. So the deployment strategy also plays a very important role there. It uses something called rolling update strategy, through which it will update the newer version step by step. Each and every instance of your pod or container will be updated one after the other to ensure high availability of your applications. So even during your upgrade, you no need to down your environment. Without any downtime, you can able to achieve continuous deployments using Kubernetes. It's a very powerful tool there. Okay, we'll talk about Kubernetes in detail in the upcoming topics. Don't worry about it. So even this demo for your Docker Compose, Docker Swarm also, I'll show you in the upcoming sessions. So, but before that, you need to understand something about the replicas. So when I say replicas means, so the point is, when it comes to your replication, okay, we are not just going to replicate the containers, even the underlying infrastructure, the production environment, the servers that is responsible to run the containers or the pods should have its own replication. So basically, the deployment servers, like when I say production environment, do you think there is only one production server there? We'll be having multiple servers. So all the servers configuration will be same. It is a replica of production servers. So why we need this replicas here at the server level? Because even if one server is down, I can have these 4 servers to support my application. And whenever there is a huge traffic, network traffic, I can able to scale up. I can able to add more number of servers to my infrastructure. If the traffic is getting reduced, I can simply go ahead and reduce the number of servers. That is what scale up or scale down, auto scaling means. So this auto scaling and all can be performed with proper monitoring. You need to continuously monitor your production environment, and based upon the monitoring metrics, you can able to figure out whether you want to scale up or scale down. I'll talk about that during your Kubernetes and monitoring modules and all. So when I say replication, it is not just about replicating your containers, it's also responsible to replicate your servers. Now consider in my production environment, I want to deploy these service with front-end layer and other stuff. So if I deploy a copy of container to run my front-end application, and if the container is down, I'll be losing my entire service. So what we do here is, instead of creating or running one container for particular layer, what you can do, you can have some replicas of it, like 1.1 like this. Similarly, you can have some replicas of your other containers as well. So we have created 3 instances of container. These 3 copies of containers will be up and running to ensure high availability of your application service. Even if one container service is down, container instance is down, your remaining container instances can able to support your application. Now, another important thing is, are you going to run all these instances of your containers in one server? If you do that, it leads to some single point of failure. If I deploy all these instances of my container in one server, definitely I cannot achieve that zero downtime. So your container orchestration tool, what is going to means, it will identify the healthy node and schedule your deployments, distribute your load to all the available servers. So copy of one container will be running in server 1, and this can be running in server 2. Like that, it will distribute your workload. So even if one container is down, I have another container to support my application. Even if one server is down, I have another server to support my application. Like this, at any point of time, your application or the underlying infrastructure should not get into any issue. You see, production environment should be available 24/7. So all these things, if you do it manually, it is not at all possible, because in real-time scenario, we'll be running thousands of services, thousands and thousands of microservices has to be deployed. Practically, we cannot do all these kind of scheduling and load balancing and auto scaling manually. For that, we have to rely on the container orchestration tool, and Kubernetes is one of the powerful container orchestration tool to perform all these activities. So yes, this is about your replication and container orchestration. Just keep this core. This is the essence of your orchestration tool. If you are clear with this, based upon these requirement and specifically when you learn about Kubernetes. See, we were discussing about this Docker build. So you can able to create a Docker file and run the Docker build command to prepare an image, right? Next session, we'll be learning about more things related to your container orchestration, basically starting from Docker Compose, Docker Swarm, Kubernetes, networking, a lot of things are there. We'll see one by one.